Okay, so we'll pick up where we left off. We said we were going to work on the left-hand side because it's more complicated than the right-hand side. And we're going to try to do whatever we can to this to make it look like or be equivalent to that expression on the right-hand side. So we start with the left-hand side. Everything is already in terms of sine and cosine, so there's not a lot that we can do. One thing that we can do, and something that comes in quite handy, is if we have something that kind of looks like 1 minus the sine squared of theta or 1 minus the cosine squared of theta, if it's something that we can multiply out to get that to show up, we know we can write those things much simpler. This is just a manipulation of the Pythagorean identity, right? We know this equals cosine squared. We know this equals sine squared of theta. So that's all I've done here. I've picked something that I can multiply that denominator by so that I can write it in a simple term, but I have to multiply it by something that won't change its value. So that's a well-chosen one. So I'm going to multiply that through top and bottom, and this is what I'm going to come up with. I'm going to have the cosine of u times the quantity 1 plus the sine of u, and the bottom, using the Pythagorean identity, can be rewritten as cosine squared. Well, I have cosine times cosine in the denominator and 1 cosine in the numerator, so they simplify. And I have a common denominator for the two terms in the numerator. So that's 1 over cosine plus sine over cosine, and there is our right-hand side. 1 over cosine is secant, and sine over cosine is tangent. So that's equivalent to our right-hand side. And as long as we continue to be able to do that, that is what makes this original equation, this is an identity, because that means it's always true no matter what angle measure that you put in there. This relationship is always true because this does indeed equal that. We just proved it. And if they're equal, then this is what we call an identity. So let's look for one more technique. Another method for proving that an equation is an identity is to work on both one side and the other to change them so that they both equal the same expression. Instead of just working on the left-hand side and leaving the right-hand side alone, we're going to work on the left-hand side and change how it looks, and then work on the right-hand side to change how it looks. And our attempt is that we can get both of them to equal the same expression. And if that's true, then again, we have proven this to be an identity. So let's start on the left-hand side. We have 1 plus cosine theta over cosine theta, so we have a common denominator to the two terms in the numerator. So we're just going to write that as two separate fractions. We know 1 over cosine is secant, cosine over cosine is 1. So now our left-hand side we've rewritten as the secant of theta plus 1. So let's go over to our right-hand side and see what we can do with it, see how we can manipulate that. The tangent squared of theta is equivalent to secant squared of theta minus 1. We've absolutely used a Pythagorean identity that says the tangent squared is equal to secant squared minus 1. We haven't done anything in the denominator. We leave it alone. This is the difference of two squares. We have something squared minus something else squared. And we know that we can write that as the first term minus the second term times the first term plus the second term. That's the difference of two squares from algebra, and we're just bringing it here into trigonometry. And the reason we are is because that helps us cancel with the term that's in the denominator. And lo and behold, our right-hand side is the same expression that we got on the other slide for our left-hand side. And if that's true, then that equation is an identity. All right, so now that we have verified identities and solved some trig problems, come to class next time and we'll work some homework problems on this. Again, this is not the only identities we'll be working with, but we're just introducing the idea of verifying identities and simplifying trig expressions. So come to class next time and we'll work some homework.